October 17th, 2024 marks the 75th year of the commencement of the Snowy Mountains Hydro Scheme. I'm Paul Michael Angus, a mechanical and civil engineer in Australia's water sector. Come with me as I explore the timeline, the components, and the challenges faced throughout its construction, as well as celebrate the amazing elements of this engineering wonder. Welcome back. Kicking on from the last episode, water from the Snowy River catchment can now be diverted from its original journey south into Gippsland, Victoria, westwards and inland, towards the Murray River, its irrigation districts, and towards the river's mouth in South Australia. Similarly, water from the upper Murrumbidgee River can make its way over the Great Dividing Range and into the Snowy catchment for storage within Lake Jindabyne, later being diverted back through the range towards the Timut River, where it rejoins the Murrumbidgee and also flows towards the Murray. We've observed in essence the first 15 years or so of the scheme under development and construction up to this point, and also seen some of the challenges faced with the initial plans put to Hudson and his team. Sadly, it's around this time I understand that Hudson was advised to consider retirement and pass on the baton to others within his team. Part of his legacy, however, would be in essence the true vision of the scheme up to this point, as very little changed following his retirement and departure. And so we continue our journey from where the remaining elements of the Lower Snowy development got progress to and brought online. We begin with a component which will transfer water back from Lake Jindabyne, see Lake Jindabyne also begin its life, revisit the Murray 2 power station coming into use as Cancove and Pondage gets its finishing touches, and watch the outflows from Murray 1 be impounded and pushed through the final mountain range, providing the remaining 550 megawatts of the Snowy Murray development's power capacity. Let's continue. Works in the Upper Snowy development would progress no further, having found the financial viability of the Kosciuszko and Munyang storages and their associated power stations falling short of the desired rate of return for their investment. During this time, they're deleted from the scheme. Island Bend is available to permit flow to either Lake Jindabyne or to Jindabyne Reservoir, where it supplies Murray 1, leaving only Murray 2 to be brought online from an energy generation perspective. Jindabyne Pumping Station and the dam impounding the Snowy River remain, and their link back to Island Bend yet to be constructed. Now, although Island Bend diverts the Snowy River in its upper reaches, runoff below this, alongside other runoff from below Lake Jindabyne, will enter the future Lake Jindabyne, alongside runoff and snowmelt from the Thredbo River. This water, due to the earlier high-level diversion of the Snowy Murray alignment, is now required to be pumped back over the range to a hydraulic level permitting inflow to Jindabyne Reservoir. Now, it seemed counterintuitive to me at first to pump water when comparing this to the arrangement of Lake Jindabyne to the Snowy Timut scheme. However, the energy needed to transfer this water is returned back as a generation capacity of roughly twice the energy used, as it falls from a taller total elevation via Murray 1 and 2. So in some degree, it is similar to a pumped hydro, only in this instance it produces more energy than was required as an input. The facility which would permit this pumped transfer is the Jindabyne Pumping Station, the only pumping station in the Snowy scheme. Constructed between 1966 and 1969, the facility would use 4 pumps, 2 pairs of pumps in series. The first, lifting water only 50 metres or so to the inlet of the second. The second unit would deal with the greater pressure needs of this transfer system. The pumping station is fitted with bypass pipework and an outlet valve, permitting the draining down of the pressure tunnels for inspection and maintenance purposes. Due to the pressures of the system being high, this facility is also, like others, fitted with a surge tank. Only this one is visible as you drive along Kosciuszko Road from Jindabyne towards the Perisher Valley. Lake Jindabyne is formed due to the earth and rockfill dam located just south of the present township, and as described in the previous episode, resulted in the old township of Jindabyne being flooded following its completion. Here you can see the new main road through the new township in the foreground, and the former township, soon to be flooded, in the background. The dam itself would be constructed between 1965 and 1967 and become the last major structure along the Snowy River to be built, with exception to the Moamba River Aqueduct. The storage itself had been in planning for several decades, but not to divert water in the manner to which the Snowy scheme would. The dam would into its future undergo major upgrades, but those will be detailed in a future episode due to them occurring after 1973. It's from this point water can either be returned to the river and its natural course, or it undertakes its journey through the Snowy Murray development. We jump back over to the other termination point of the Snowy Murray development, with only Murray 2 remaining to be completed and brought online. Murray 1 Power Station and Cancoban Pondage are already in use, having also excavated the work area for Murray 2 Power Station during this process. Murray 2 would be built over 3 years, and due to it not being finished before Cancoban Dam, would require a small earthfill cofferdam be placed downstream within its tailwater channel to prevent inundation of the work area. Similarly, the pressure pipeline to the last mountain range between Murray 1 and Cancoban Pondage would navigate the landscape of the region, with 2 4 to 5 metre diameter pipes traversing just less than 1.5 kilometres once daylighting from below ground. Murray 2 Power Station, like Plymouth 1 and 2 power stations, were matched closely with respect to flow, but differed with driving pressure head. 4 turbine and generator units were installed, each roughly 138 megawatts in capacity, providing a total of 550 megawatts to complement the existing 950 megawatts from Murray 1 Power Station. So now we have Murray 1 complete and operating, alongside Cancoban Dam and Pondage to regulate flows to the Murray River. Murray 2 Power Station, pressure tunnels and pipelines are also on their way to completion. However, a final dam to impound water below Murray 1 is required. This is where Murray 2 Dam comes into existence. Now, in the previous episode, I mentioned a weir had been built just downstream of Murray 1 to ensure adequate back pressure on its turbines was available. The Murray 2 Dam would, in essence, remove the need for this structure, as both power stations operate in unison. Murray 2 Dam would be an arch concrete dam, visually a miniature version of Timot Pond Dam, being only some 42 metres in height. Fascinatingly, given it would take 3 years to build, 3 diversion conduits were left open whilst the structure grew overhead. This would permit flows from Murray 1 to continue without impacting its operation. These 3 openings were later sealed with concrete, as a separate opening permitted controlled releases from the dam into Cancoban Back Creek where needed. Like most dams, an outlet structure would permit flow to enter the pressure tunnels, making its way towards Murray 2 Power Station via the Trans-Mountain Tunnel and pressure pipelines. With the Murray 2 development commissioned, the Snowy Murray scheme would be complete, enabling runoff and snowmelt to be stored long-term within Lake Jindabyne and flows downstream of Jindabyne, Island Bend and Thredbo to be pumped up into the development from Lake Jindabyne. So now we're at 1969, 20 years into the construction of the combined Snowy Mountain scheme. Now the Snowy Murray development is completed in its entirety, with some of the originally proposed elements being deleted due to better information informing further investment beyond this point may not be warranted. The Snowy Murrumbidgee, Jindabyne, Tuma, and many further rivers and tributaries are being captured to feed the colossal transfer of water inland. Nominally 24,000 gigalitres, somewhere along the lines of 3 to 5 Sydney harbours each year. A huge boost for irrigation and agriculture across the regions of New South Wales and Victoria, but at an environmental cost, which sadly would only be better understood in the decades to follow the scheme's completion. From an energy productive perspective, we're now at 2,160 megawatts of the 1973 nameplate capacity of 3,740 megawatts, with only works in the lower Tumut development yet to be built and commissioned. Our next episode looks to the remainder of the Snowy Tumut development, which will branch the next 4 to 5 years leading up to 1973, with Blowering Dam and its power station, Jaunama Dam, Talbingo, and also the Tumut 3 power station, the biggest capacity hydro power station within the Snowy scheme during this period, being completed and topping out the 3,740 megawatt capacity. Thanks again for watching. Please join me for the next episode in this series, exploring and celebrating the Snowy scheme and its 75th anniversary.